So why do we need a digital signal processor or a DSP in car audio? Well, first of all, for those of you who have worked in the sound field, you all know how hard it is to move sound around and create a good sound image whenever a person isn't sitting in the perfect spot. You know that if you're sitting in the right spot, you get a beautiful sound image. And if you're standing over beside the side of the room, you don't. Well, that's where the DSP comes in. Digital signal processor is a tool that allows you to correct problems that occur whenever someone is not standing in the sweet spot or sitting in the sweet spot. Now, as you can see, there's a speaker back here behind me. There's two speakers right here that are down on the floor and really close to my left side. And you have a speaker right here, which is almost in front of me. I'm so close to this wall. Then the speakers over there are way over there, and they're way off to my right side. That one, again, is down on the floor, firing toward this center console. It's way out of place. Everything about this is the worst possible case scenario for making a sound balanced and full and rich and putting the sound field out in front of you where you want it. Now, the digital signal processor is the tool that allows you to fix all those problems I just showed you. And just like any other tool, like these guys, it's only as good as the person who has the tool in their hand. So along with getting the tool, you also have to learn how to use that tool to enhance your listening experience. And to have someone who is qualified to use a tool in its best ability is awesome. But for most of us, we're going to be using the thing ourselves. So let's talk about that. Let's take a look at this multimeter. Now, for most people, this device is how they do one thing, right? You may use it to check voltage in a house. You may use it to check voltage in a car, at which point you would set it on 20 volts, DC. Turn it on, and then use the leads, test the voltage. You may also use it to test ohm load. At one point, you would turn it down here to, say, 200 ohms, where the horseshoe is, turn it on, and touch these two leads to a speaker to see what the resistance value is between them, the static DC resistance. But there's other uses for it. Checking for capacitance, checking for amps. Of course, like I said, checking for AC voltage, right? There's a plug down here that nobody ever uses. That's for checking, I think, don't quote me on this, but I think that's a transistor check. The point is, this tool has one use for a lot of people, but it actually has tons of uses depending on how knowledgeable you are about the tool. So while this screwdriver makes a pretty good hammer, it makes a good thing to poke holes and stuff, it also has 4 different screwdriver bits to allow you to remove fasteners. And if you look, there are 2 different sizes of nut drivers available right there. So there's 6 tools. I think it says that on the handle, 6 tools in one. They're leaving out the fact that it is a hammer and a pokey tool, possibly a weapon. If you know how to use all the bits on your tool, you can get more out of it. Now, a digital signal processor is no different than either of these two things. It allows you to run a stereo signal at minimum. Well, technically at minimum, a mono signal, but we're just going to go with stereo for right now. To run a stereo signal out of your stereo into the digital signal processor, and then run multiple channels out of the processor into different amplifiers. That's the first thing it does, is it allows you to multiply your channels and have different channels from your stereo. If your stereo has a front and rear and a left and right already, you could run all 4 of those channels into the processor. You can go into that processor and assign each one of those channels to do different things throughout the processing environment. Now, you have, say on a simple processor, you have 4 in, 6 out. That means you can plug anywhere from 1 to 4 different signals into the processor and have anywhere from 1 to 6 channels out of the processor. Inside that processor, you have the ability to control just about anything you can think of for each individual channel. First of all, you can assign one of those 4 channels to a channel, or you can assign 2 of those 4 channels to a channel. If you're going to run a subwoofer on, say, channel 6, you could assign left and right 1 and 2, right, whatever they are, into that sub signal so that you're getting the subwoofer frequencies from the left and the right side. If you're going to run a stereo sub, you could do the opposite. You could say, I want to run 5 and 6 for subwoofers. And then you could assign channel 1 to 5 and channel 2 to 6. I mean, channel 1 to left and channel 2 to right. Any combination. Or you could send 1 and 2 to both of those 2 channels. Like I said, it's completely flexible. It is a tool. Whatever you do with it is your thing. Also, you have the ability to run a parametric equalizer for each individual output channel. So, and you may say, well, why would I want to equalize this speaker different from this speaker? Well, if you sit in front of a speaker, right, put it over here a little ways away from you and point it at your head, it'll sound one way. If you move that speaker over here, point it across the room this direction, where you're sitting beside it, it's going to sound totally different. Having the ability to individually address each of those 2 channels and equalize it individually, you can make this speaker seem like it's turned more toward you, and with time alignment, which is the next thing we're going to get into, you can make it seem like it's further away, matching the one over here. Okay? Therefore, you sound like you're sitting between equal distances 2 speakers that are facing at you. That's the perfect solution. So having the ability to individually equalize each driver is a big deal. It allows you to do that flexibility to make that driver sound more like it's in the proper orientation. The second thing I mentioned was time alignment. Your ear is good at picking up whether this is happening here or happening here. One of the things it does is measure the distance and time. It knows how far away something is based on how long it takes to get to this ear and how long it takes to get to this ear. So the difference is perceived, and it can tell the difference. So if you've got a driver sitting right here and another driver way across the room, this driver's sound is hitting this ear and this ear, right? It can tell that distance is different from this driver over here that's hitting that ear first and that ear. Time alignment allows you to delay this speaker so that its sound waits a set amount of time that you decide and allows the other speaker's sound to get to your ear before, so that they both travel the different distances, but arrive at your head at the same time. And that's what time alignment does. That's another way that this tool can be used to trick your brain into thinking that you're sitting in the center and you have the best possible everything. There's other tools in a digital signal processor also. Very common is phase switching. And this is kind of a more advanced area, but I will touch it. So as a frequency moves through the air, the frequency is shaped kind of like a whole bunch of M's strung together. And the higher that frequency is, the quicker those M's go up and down. Low frequencies have long M's, okay, traveling to your head. Now, sometimes when the sound gets to your head, it'll be out of phase. So this M will be on the up and this M will be on the down. And what happens then is whenever those two opposite frequencies meet at your listening position, it causes cancellation, phase cancellation. It basically creates what we call a null or a non-existent sound. If you've ever hooked up two subwoofers out of phase with each other, they don't get very loud. Same exact concept. So with phase switching, you can take this one that's on the upstroke and this one that's on the downstroke. You can switch the phase on this speaker so that now they're both on the upstroke at your head, which means that sound is going to be there and present. And like I said, this is a fairly high-end use, but it is used. You've got your crossover frequencies. So you've all set those little potentiometers on your amplifier to where you don't want the amplifier to play below this frequency or you don't want it to play above this frequency. That's your crossover frequency. And that allows a driver that's more suited to play low frequencies to have a crossover point with a driver that's more suited to play high frequencies. So as this driver is starting to get out of its job range, the volume it outputs is going to drop. The next driver in that series is going to cross over and start playing, and the two of them are going to be able to reproduce the full range, or the 3 or the 4, or however many you have. At that point where they cross each other is your crossover point. Then the angle, the amount that it loses volume, right? If it loses volume quickly or loses volume gradually, that's your crossover slope. And then the curve, whether it be a straight line or a humpy curve or a swoopy curve, that is the crossover type or the curve. So, and the Butterworth is one of those examples. So you have your curve, your slope, and your frequency, all these crossover points. For each individual driver, left can cross over at a different place than right. What? That's heinous. Yes, you can cross over. You can make this mid over here play a higher frequency than this one. These are things that they're advanced subjects, but yes, sometimes the driver that's up here, the 3-inch mid you have, may be better or in better position to play, say, 1,000 hertz than the driver that's down here in the door firing that direction. So in that case, you might would cross that over lower so that this driver's cutting off at, say, 700 hertz and bring in this one to play from 700 hertz and up, so that that frequency that you're missing, right, because the driver's out of position, can be reproduced by a different driver. Also, and over here that problem may not exist, so you may have these crossovers at a different point. All of these things are possible with a digital signal processor. You can set a crossover point for a pair of speakers with an amplifier. You can say everything coming out of these two channels crosses over here. But you can't do that trick I just told you about. Another key thing is being able to flip phase and flip it back. And we're not going that deep. because that's getting really in the weeds. This is a basic concept. But having said that, there are more features that a crossover gives you, that a digital signal processor gives you. Having the tool to do the job means that you can start by learning how to test for AC voltage. And then you can learn how to test for DC voltage. Then you can learn how to check for ohms of resistance. The tool is still useful just as an AC voltage checker. But as you learn more things, you'll find there's more tricks that tool can do. And you'll get more and more advanced and more capable at learning how to use all the features of that equipment. A digital signal processor is an amazing thing. And if you guys have been on the fence about getting one, just do it. If you don't know how to set it up, you can go to someone who does, have them create a tune for you, and then save that tune, because you can create multiple tunes. You can save their tune, and then you can go in there yourself, have them create a second tune, which just sets your crossover so you don't blow things up, and then you can play with that tune. And you can switch back and forth between the one they made for you and the one that you're creating. The main thing to remember is don't try to play frequencies lower to your tweeters than they can reproduce. So if you're using hard limits on your tweeters, like a capacitor, for example, then they're safe. But if not, you need to make sure that you've got the crossovers on those tweeters set high enough so that they're not trying to reproduce, low frequencies, or they will instantly not work anymore. Other than that, and trying to send crazy low frequencies to your 6s and whatnot, other than that, you really aren't going to break anything. Just keep the volume down and have fun. Watch video tutorials, learn about things, learn all the tricks to the trade. The person who sets your DSP for you the first time, have them give you some tips. They'll be able to get you started. Watch tons of videos about it. You'll learn little tricks from everybody. And then just get out there, take a nice glass of cold tea out there with you, and sit down and tune. You'll find that it's very cathartic and relaxing, and you'll enjoy it very much. And the end result is your ears will be very tired, and you'll need to come back the next day and listen to what you did, because you're going to have ear fatigue by the end of the session. But after you get done learning and getting somewhere in your tune, you're going to learn that it's very unique and very interesting to play with. And you're also going to end up with a stereo system that sounds like you're in Symphony Hall, or a concert, or a bar, or a club. Whatever it is you're shooting for, you're going to get the sound you want. And a DSP will make that possible. Guys, I hope this was entertaining, helpful, and instructional. If it was, be sure and hit that subscribe button down below. Give me a like, and most importantly, leave comments. I know I missed a whole lot of things. Some things were a little fuzzy. I'm pretty sure that's not what you use this for. This thing right here, I don't remember what it's for. Like I said, I think it's for testing transistors. I've literally never used that for anything, but I think that's what it's for. So, you guys know what that's for. Put that down in the comments too. I'm all about interacting with my audience. You guys are great, and I love every one of you. And it's hot, so peace.